Hello everyone, welcome to my channel Keep Calm and Love Maths. So today we will discuss about a new topic, and that is binary operation. So and I have a request for you all that I am starting sessions over HS first year also. So please share the video link of my previous class, and I will keep it in the description box, and so share with your brother, sister and cousin. So let's proceed to the session. So we have binary operation, which is very important. Now what is a binary operation? First of all, this binary operation is a kind of function. So it is a kind of function. As we have learned how a function is formed, how a composite function is formed, how an invertible function exists. So here this binary operation is a kind of function, and it is defined on a set. And this operation goes from, and binary operation goes from, suppose the set is A, the Cartesian product of the set to the single set. So binary operation is a kind of function which is based on a set, and it goes from Cartesian product of the set to the set, right? So the definition will be like binary operation on a set A, and binary operation is denoted by a star. A binary operation star on a set A is a function from A cross A to A itself, such that for an ordered pair AB belongs to A cross A, star of that elements AB belongs to the set. So a binary operation star on a set A is a function from A cross A to A, such that for any ordered pair in the Cartesian product, star of these two elements belongs to the single set. This means A star B. We usually denote star of AB as A star B. Or we may write, if A star B belongs to A for all AB belongs to A, then star is called a binary operation on the set A. The set A is called closed under this operation star, right? Or we may call as, if A star B belongs to the set A for all AB belongs to A, Then star is called a binary operation on the set A, and the set A itself is called closed under this operation star. So this is the definition of binary operation. Now what will be the examples of binary operation? So let's see. So basically binary operations are addition, multiplication, subtraction, and division. These are the basic binary operations, but there are also some other binary operations: composition of functions defined on a single set, so sometimes composition of functions defined on a set, it will be also a binary operation. We have already learned what is composition of functions, right? And also matrices. Some matrices operation also be examples of binary operations. So basically binary operation means addition, subtraction, multiplication and division of numbers and matrices. So to see some examples, we may have addition on the real numbers, on the set of real numbers. Is an example of binary operation. How? We all know the set of real numbers, right? We all know set of real numbers. Now, since addition is the binary operation here on the set of these real numbers, because for any two real numbers, A and B, the sum of these two real numbers is again a real number. So, addition on the set of real numbers is a binary operation because for any two real numbers, the sum of these two is again a real number. Similarly, addition on the set of natural number is also a binary operation. Multiplication on the set of natural numbers is a binary operation. So there may be many examples of binary operation and various examples of binary operations defined on different sets, right? So basically, I have given three of them. First one is addition on the set of real numbers is a binary operation. Addition on the set of natural numbers. Multiplication on the set of natural numbers. How? We all know the set natural number starts from 1, 2, up to infinite. If we take two elements, suppose 1 and 19, if we add these two numbers, we will get 20. And 20 is again a natural number. Therefore, addition on the set of natural numbers is a binary operation. Similarly, if we take the same elements 1 and 19, and if we multiply both, then we will get 19. And 19 is again a natural number. So multiplication is a binary operation on the set of natural number, right? So I hope this is clear. Now let us take a look on some illustrative examples of binary operation. So the first one is a star b equal modulus of a minus b on the set of integers z. Since z is the set of integers, now we have taken two elements a and b, and this is defined as modulus of a minus b. So is this a binary operation on z? Now we know modulus function takes only positive values. Again, let us take two elements in the set of integers. Suppose minus 15 and 30 belongs to z, right? Now if we subtract these two elements, if we subtract 30 from minus 15, we will get minus 45. And now modulus of minus 45 is 45, and 45 is an integer, we always know. So that means for any two elements in the set, we have found the binary operation of these two elements belonging to the set also. Therefore, star is a binary operation on Z. So here we can write it as, since a star b belongs to the set of integers again, therefore star is a binary operation on the set of integers. Hence it is done. Now the second one, a star b is defined as a to the power b on the set of natural numbers. Now we all know what is natural number. Let us take two elements. Let us take a equal 2 and b as 10. Now, by the definition of this operation, in the equation, we will get 2 star 10 equal 2 to the power 10. And 2 to the power 10 is a number which is positive and it belongs to the set of natural numbers. So, this star is a binary operation on the set of natural numbers. So we can write, since a star b belongs to n, therefore star is a binary operation on the set of natural numbers. Right? Is this clear to you? Now the last one, number 3. A star b is defined as a plus 4 into b square on the set of real numbers. Everybody knows what is a set of real numbers. Now, it is defined for two elements as a plus 4 into b square. Again, obviously a star b belongs to R. It is very obvious. Since this is belongs to R, therefore star is a binary operation on R. So let us take an example. Let a equal 2 and b equal 0.1. So 2 and 0.1 are real numbers. Now 2 plus 4 into 0.1 square. 2 plus 4 into 0.01. 2 plus 0.04. And finally 2.0. So since we know about real numbers, therefore we can say that this is a real number. For two elements 2 and 0.1, we get their definition as defined above. Again, a number which belongs to real number. Therefore, star is a binary operation on R. So these are done. Now some binary operations have rules also. So the properties of binary operation. A binary operation star defined on a set and goes from Cartesian product of that set to the set, and this binary operation star is called commutative if for two elements A star B equal B star A for all A and B belongs to the set. So binary operation star is commutative if A star B equal B star A for all A B belongs to A. So see with some example. Suppose addition is a binary operation on set of natural numbers. Now let us take two elements which are natural numbers 2 and 10. If we first take 2 plus 10, it will be 12 belongs to n. Again 10 plus 2 equal 12 belongs to n. So in that case we can write 2 plus 10 equal 10 plus 2. So the for the set of natural number n, if we take the binary operation as addition, so this is a commutative binary operation. So here addition on n is called commutative. Now number 2, a binary operation star is associative if A star B of star C equal A star of B star C for all these elements in A. So again, this associativity can be seen on the binary operation addition on the set of natural numbers also. So let us take three elements 5, 9 and 3 belonging to n. Now 5 plus 9 plus 3. First of all, since here is the bracket, so 5 plus 9, 14 plus 3 equals 17, and 17 is a natural number. 5 plus of 9 plus 3 will be 5 plus 9 plus 3, 12, and 12 plus 5 again is 17 belonging to n. So since the results are same, so we can write this equal this. So star is associative on the set of natural numbers. But yes, we can check also for division, multiplication and subtraction also. So how a binary operation is called commutative, I am just showing with the binary operation addition, but you can check it for other operations also. And now, how an operation has an identity element in the set. So let's see. Again, I take the addition as binary operation on the set of natural numbers. So what will be the element for which we can prove this statement? To show this statement, let us take an element in n who belongs to n. Now, is there any element in the set of natural numbers which operates with 2 and again gets the 2 itself? Is there any element? So, yes, we have the operation addition. So, 2 plus 0 will be nothing but the element itself. Since operation of this 0 which the element we are taking is again the element itself, therefore 0 will be the identity element on the set of natural numbers with the operation addition, or 0 plus 2 again is 2. Since A star E equal A itself equal E star A for all elements in A, therefore 0 will be the additive identity on the set of natural numbers. So 0 is additive identity on the set of natural numbers, right? If we see the binary operation multiplication on a set of natural numbers, then how the identity element be like? So here again taking the same element 2 belongs to n. Now is there any element in the set of natural numbers which operates with 2 and again results in 2? So yes, if we take the other element as 1, then it will result only the number itself. So A star E equal E star A for all elements in the set of natural numbers. Therefore, 1 is the multiplicative identity on the set of natural numbers. So I hope how a binary operation carries an identity element. So I hope this is clear to you, right? You can see it here. Now, how a binary operation has an inverse element in that set. So a binary operation star from A cross A to A has an inverse element B, the inverse element is B, belongs to the set for all elements like A belonging to A, such that A star B equal E equal B star A. The definition of inverse element is like if we have an element A and if the element A operates with the inverse element, then it gets the identity element. So A star B equal E equal B star A. So here B is the inverse of A and E is identity element. Now how an inverse exists in an operation and defined on a set. So let us take the set of integers. Then let us take the operation positive addition. So if we take the element 2 belong to the set of integers 10, and we all know that additive identity is 0 because I have done with the set natural numbers, so 0 is the additive identity. Now we will have to find 0 here. So is there any element in a set of integers such that which operates with 0 and results in 0? Sorry, operates with 2 and results in 0. So yes, if we take minus 2 in the set of integers, so if we take the element minus 2 in the set of integers, then, and since here the operation is addition, 2 plus of minus 2 will be 0 equal minus 2 plus 2. So therefore, in the set of integers with the operation binary, with the operation addition, minus 2 will be the inverse of 2. So I hope this is clear to you. So that's all about these properties. So applying these properties of binary operations, we will solve the problems on the exercise section, but in the next class. So till then, take care and thank you for watching this video.